Hi, so in this video I'm going to quickly go through merging. So in the previous video I talked about branches and how you check them, you sort of take this copy of your code, and we did a quick example where I made a branch, I made a commit, and I committed this and pushed it to the remote origin, right? So now we're at the point where we have, if we look at git log, we have this branch called feature adding another line, and it's got this commit to it. But if we see our master branch is actually a bit behind, it's only up to this point. So if we look at the slides, we'll see essentially before we branched, we were here where we had our 3 commits or whatever, and master was just pointing to this commit. This was our head, right? And so we saw this head. As you can see, head is here, but also if you look at branch all, you'll see that the head is actually just pointing to master, right? And now what we did is we created a new branch. And so this was the moment, like when we had a situation like this, was when I first created my branch before I created my commit. I had simply just taken the repository and made another pointer that points to the C2 commit. So that's when they were both equal. And then what I did was that I actually created my commit here, and this is this commit here. So I created a commit and I actually added a commit here, C3, and then the pointer to my branch, in this slides case, this ISS53, and then this ISS53 points to this most recent commit. But master is still behind. And so there are a few different ways that, like when you're creating branches and creating new commits, that you have to then merge these back to the master branch. And there's pretty much 2, or as far as I'm aware, sort of 2 different situations. One of them is very simple and one of them is more complex. And so everything that's sort of complex falls into this more complex situation. But I think, we'll go through, here. So essentially, this is where I'm at the moment. Now I want to merge, and so it's the act of integrating these 2 code bases together. So I have my branch code and I have my master code. Now I want to sort of integrate them into each other. So on my feature branch, I finished implementing this feature. So I'm now I want to merge it into my core stable master branch, right? So in my case, also sort of explained by this dot point here, I only need to move the head pointer or the master pointer to the most recent commit. So my whole repository looks like this. And as you can imagine, since I've only added this one commit, if I want to merge this, like in this case, it's not really a merge. If I want to merge this commit, all I have to do is take my master pointer, my master branch's pointer, and move it to here. And this is called a fast forward merge, because I'm not really actually merging anything. I'm just saying, yeah, this commit is now the head of my repository, right? And so this is what this fast forward merge is. It just moves the head pointer. But then we get to sort of more advanced merges where you actually have different changes or from 2 separate things that actually need to get resolved, right? And so Git handles most of this automatically, and it's quite good at it. But as you can imagine, sometimes the same line is modified by 2 separate engineers modifying like the exact same line. And so Git doesn't know which line it should choose. And so the way that Git handles this is essentially it will just flag this as a conflict called a merge conflict and say, hey, I need someone who has knowledge of this code to come in and choose the correct line, right? Which is good, because this way that any conflicts, any really non-trivial conflicts are handled by someone with knowledge that can actually create a stable code base from these conflicts, right? So when you get to a situation, this would be a figure that would explain a situation where 2 engineers have created changes. So we have like engineer number 1 working on this ISS53 branch and engineer number 2 working on this hotfix branch, right? And so now we can see that we actually have 2 parallel development branches that share a common ancestor. And so this common ancestor is what, or sharing of a common ancestor is what can actually create these merge conflicts. And here, as we can see here, And how these conflicts are handled, which I will show you in a minute an example, is by doing what is called I think it's called a three-way merge or something. But going to this figure, yes. So going back to here, as we can imagine, if I take my highlighter, and if we just imagine this branch doesn't exist, like let's just cancel out the yellow branch for now. When we get to this situation, merging becomes very straightforward. It becomes, like we had before, a fast forward merge, right? So if we go down to this figure here, we can see that we have done this fast forward merge. We've moved C2, we've moved master up to C4, right? So this guy here was a fast forward. So this was just a fast, undo, and I need my pen. Fast forward. So now we need to merge ISS 53 into master, which is now moved forward. And this is going through a common ancestor. And so this is when we can get conflicts. So we'll go to an example scenario. Imagine that we have a function in its system and that developer 1 has renamed it to init system camel case, and the developer 2 has renamed it to init system snake case, right? Now we want to merge these together, but we'll get a merge conflict because they share a common ancestor. They share the commit where this function was called init system, right? And so what Git does is that once you do this merge, it will let you know, hey, there's a conflict in this file, main.c, right? And so how Git handles this is it actually puts in these conflict resolution markers, which are quite easy for a developer to see and know that there is a conflict right here. And so what this would look like in the case of two branches using different casing for the function name would be that it would say, hey, the head branch, so head in this case would be this guy. So like after the fast forward merge, the basic one, it's saying head has a snake case, camel case, and this snake case branch has snake case. And now as the person responsible for merging, you would need to come along and delete the one that you don't want, including you also have to delete the Git markers because these are actually added in as ASCII text to your file. So let's say we want to keep this one, keep this one. Then we would delete the other one and the markers, right? So once we've deleted what we don't want, we would then create a commit. And then this is essentially a merge conflict commit, right? So you would then add it like normal, create a commit saying, hey, commit message like merged blah, blah, blah branch into blah, blah, blah. And then once this has all been handled, and should your code be stable again, you can push this and continue on. So if we look into a diagram of what just happened, we had fast forwarded master to here, right? So we have, this is a fast forward. And now we need to merge this guy, ISS 53, into master, right? And so what it did is we had essentially in here, we had conflicts. It did this sort of like three-way merge between the 3 and the common ancestor. And then it told us, hey, we had these conflicts and we resolved them. And then we added them. Like conflicts were added to this. So this is the conflicts were notified. We were notified of conflicts. We resolved them. We added them to a commit and we created C6, which is a resolved merged branch with both changes in it, right? And so this is the basic sort of method that you'll go through when you have merge conflicts, and you should understand that merge conflicts come about from two commits with a common ancestor having modifications to the same code base, like the same exact code lines, right? So I think that will be the end of the slides of this, and I'll quickly do an example of this, right? So let's check out master. And we want to create two branches that diverge. So essentially what I'm going to do now is I'm going to create, if we go to this diagram, and I'll get rid of my messiness, I'm going to create these two guys here, right? So to create them, I have to firstly branch here. This is one branch, and branch here. So if I'm on master, like I am now, get status, I can create branches, let's say branch, let's keep it really basic and call them branch 1 and branch 2. Now you'll see I have my old branch because I haven't deleted this yet. Quickly on deleting branches, get branch -d feature, and then no longer there. But I have this branch 1 and branch 2, and now they have diverged, or they're not diverging yet, but they're both being branched from master, from this. They all are at the same commit, right? Now what I'm going to want to do is I'm going to want to create changes on both files, right? So I'm going to check out branch 1. Now we want to create a conflict. So I'm going to modify our file, and I'm going to put a second line that is awesome. And now I'm going to check, I'm going to commit this. So git commit. Now I'm going to use the -am option, right? So if we look at git status, we'll see that the modifications, tracked modifications, meaning the files that git is looking at, we'll see that we have modifications to our file.txt. Using the git commit am, using the -a option, we'll take all tracked modified files and add them to commit. So this is useful for when you know exactly what has been modified, but it's also, you should be careful using this because you can quite easily commit stuff that's not relevant to the commit. But so I made this second file more expressive. Second line. If we look at git log, we'll see now that branch 1 has got this commit in it, and that origin, master, and the branch 2 are all here, right? So now we're going to check out branch 2, and we will modify the same file. So this guy is the same as master was, so we don't have the modifications we made on branch 1. Second line is not so great, right? So this guy is a bit of a pessimist. He's thinking second line, nah. So we use git commit. We'll look at git status again, and we'll see that the modifications happen to our file. So we can git commit am and say the second line isn't what it's hyped to be. Now if we git log again, we'll see that from branch 2's perspective, it has this new commit on master. So we're now at this situation here where we've created C4 and we've created C3, right? So now if we go to, we want to now merge them to master. So we want to go and do what we see here, right? We want to create C6. We will then firstly merge branch 1. And so this should be quite a straightforward merge, because it will be a fast forward. Now it should be noted, when you want to merge branch 1 into master, you have to check out master, and you use the git branch command to tell you which branch you want to merge into the branch you're currently on. So we'll see here, I have checked out master and I'm on master. Now I'll git branch to show my branches. I want to merge branch 1 into master. So that means I will use git merge branch 1. Now this is a fast forward merge like we expected, right? We have just taken master and moved it up to our next, why is this not drawing? Anyway, we've just moved our master's pointer up to the commit that we created on branch 1. We can see here branch 1 is at this commit and master is also at this commit, right? So now we want to merge branch 2 into master. So now we're going to have this problem where we have modified the same line on 2 branches with a common ancestor. So if we merge branch 2, conflict. And so if we look at git status, it will show us an unmerged file, meaning that there are errors in this file that we need to look at. This was also told to us here. We have merge conflicts in our file.txt. So we look at our file.txt, we will see these markers placed in there by Git. The head being after the fast forward merge, essentially the changes from branch 1, where we wrote a second line is awesome, that is awesome, and then we have from branch 2, a second line is not so great. This is showing us that the branch 2 has this contents, and our current head after the first merge has this line in it. Let's say that we are pessimistic and we think that branch 2 was correct. Then we would go and we would delete the annotations and the current changes, and we would then also delete the other annotation that's saying what's from branch 2. Now we've modified the file, it's back to how it was, or it's how it should look. In a normal project, this should hopefully be some sort of a stable form, like stable state. And we can look at git status, we'll see unmerged, and what we need to do, like we mentioned here, we need to then create a commit that shows that we've resolved the merge conflict. So we're going to do that. We're going to add our file. We're going to get status. We can now see that the changes have been added to the commit. They are no longer being listed in an unmerged path. So Git now has been notified that we have resolved the merge conflicts in this file. If you have lots of merge conflicts and lots of files, you'd see here under unmerged paths, you'd have lots of different files listed, and you sort of go through sequentially, fix them and add them. And so that and then once you've finished them all, you should have all of your files added to your commit, and you can now then create a commit. So we'll say resolved merges from branch 1 and branch 2, right? And so we can then push this to origin and master. So then this will be useful because then if I go into the web interface, I'll be able to better see what's happened. If I go into my commits, I will see this was the commit made on branch 1, this was the commit made on branch 2, and this is the resolution of the two. So if I look into the actual diff, you'll see that this was exactly what we did on branch 1, this is exactly what we did on branch 2, and then you'll see the merge of the two. Because we decided to keep branch 2, we got rid of the changes made from branch 1, and then we added the changes made from branch 2, right? So but looking at git log, we have our two branches stuck with it where they're pointing to their most recent commits. We can probably now go ahead and delete these. I'll show you how to do this in a second. And we now have the master sitting with the merge conflict commit. Merge conflict resolution commit, right? And so we are now, we have created this C6 commit, so we're safe. So now after you've merged something, you will get left with these branches. So we see here that we have branch 1, branch 2, which we've not pushed to the remote. So that getting rid of those is as easy as going git branch -d, branch 1, and branch 2. Now before git branch all, we pushed this feature branch to the remote and we deleted it locally. So we can see that we don't have it on our machines, but if we go into the Git repository, we still have the problem that the branch is showing up, which we do not need anymore. Now the way of deleting branches on a remote is slightly different. We actually push to origin, but we specify that we want to delete the branch. So it's called feature, yes. So we want to push a change essentially to origin where we want to delete the branch feature added on another line, which is currently at the origin remote. Unable to do that, does not exist. Oops, sorry. This should just be adding another line, right? So there we go. Now we can see that we deleted the branch, and if we refresh this here, we will see that this branch disappears. This is sort of just the cleanup. If you don't really need your branch to be on the remote, then if you just don't push it, you don't have this problem. But if, for instance, you wanted two people wanted to work on the same branch, you would have to push it to the remote so the other person can pull it and check it out, right? So now that I've gone through merging, I've got some more stuff that I want to go through, and I will go through that in a second. So, next video.